Okay, hey, how you doing? Now, this is Monday again, isn't it? Wow, Mondays just keep coming so fast. Well, we're starting a new chapter today, chapter 10. And you know, chapter 9 was about geometry. Chapter 10 is about geometry too, also, but it's not exactly the same. You're going to find that we're going to be measuring the area of parallelograms. We're going to be measuring the area of circles. We're going to be finding the circumference of circles, finding the area of triangles. There are a lot of neat things that are going to happen in chapter 10. But we need first to review some of our prerequisite skills. And so today, and for the practice today, you're going to be doing this page. It's page 512 in your book. And so I'm going to go over a couple of these things that you need to know in order to be successful in chapter 10. All right, so chapter 10, our preview of prerequisite skills. Oh, let me mention, you need to have a compass this chapter. You need to have a compass, all right? A protractor, a straight edge, we've already had that. We have that. All right, but make sure you have one of these tools for drawing circles. It's really neat. We're going to use it for some great stuff. So that's a requirement. Not today's lesson or practice, but you will need this starting pretty soon. Make sure you have your compass available. All right, first off, one of the things that we need to review is about area. Because we're going to be talking about the area of a parallelogram, area of a circle, area of a triangle. And what we mean by area is the surface that's covered, the amount of surface covered. And you always measure area in square units, such as it'll be 20 meters squares, 20 square meters, 20 square centimeters, or 20 square inches. So whenever you give your answer, and so if your answer for an area, make sure you have an exponent of 2 over the measure, right? So area is very different from perimeter. If I wanted to find the perimeter of this chalkboard, I would look at the silver, the aluminum part around here, and I would measure its distance. I would say perimeter equals 2 times the length plus 2 times the width, right? There's one width here, 2 of those. And that would give me the distance around the outside. But when I'm talking about area, suppose I wanted to cover this whole board with wrapping paper. Well, how many square feet of wrapping paper would it take? Well, that would be the area, the surface that's covered. Another thing you need to remember is about a circle graph. Now, we learned about circle graphs in the past, and what we're going to be doing with a circle graph this time is we're taking a circle graph and we're going to be reading it, all right? So just today's practice has us at the ages of 43 U.S. presidents, okay? Let's see. And the ages, and obviously that's not today's president being listed here, right? Because he's much older than these. But here we had those that were relatively young, 40 to 50 years old, 9 of them, of those 43. Those that were 51 to 60, 25 of them, 51 to 60 years old. And here today, Mr. Frazier, if I were president, I would fall into this red group right here. I guess red means, trouble. 61 to 69 years old, they would be 9 of them, all right, of those 43 U.S. presidents. All right, so I love circle graphs because they really kind of put into a comparison big pieces of pie, smaller pieces of pie. I think the real reason I love them is they remind me of pizza, all right? I just can't look at that circle like that without thinking pizza. And so here we go. How many presidents were 51 years or older? I wish it could just be, you look at one color here and you got the answer. But actually, 51 years is this yellow, and older would be 61 to 69 also. So what do we have to do to those two numbers? We're going to have to add them, right? The number of presidents that were 51 to 60, 25. The number of presidents that were 61 to 69, 9. 25 plus 6 plus 9 is what? 34. So you would just label that and circle it like that. So read the circle graph. Remember the skills that we've already learned, but just kind of review them. Here's something else that you need to know. You need to remember about a right triangle. What is a right triangle? Well, it's not a wrong one, right? No, a right triangle is a triangle with a 90-degree angle, all right? The others, of course, are less than 90, so they're both acute. But here we have a 90-degree angle in a right triangle. We also learned about parallelograms before. Now, parallelogram is just a quadrilateral with opposite sides parallel. It's a square a parallelogram. Don't look at me, by the way. Yes, it is. Are the opposite sides parallel? Yes. So a square is a parallelogram. I just happen to make it tilted, all right? That's a parallelogram too. Then we learn about finding area, and we're going to review that in just a moment here. So the area of a rectangle equals length times width. the area of a square equals the distance of one side on that square times itself. Now, an abbreviated way of writing something times itself is to use the exponent of 2. So area equals s squared in that case. So let's find the area of this particular rectangle. And this is one of the problems, of course, today that you're going to be facing. So let's work this one together. So first you write the formula, as we do in 6th grade all year long. The first thing is we write the formula without the numbers in it. All right. So area equals length times width. You write that first, and then underneath that you rewrite area equals, and length is 8 times width of 4. I'm using parentheses as showing you that these are a multiplication process. 8 times 4 is 32. And since the measures were in feet, I also write the answer in square feet. All right, so that's not hard, not just something that we're reviewing and doing for prerequisite skills. Now you're also going to be asked to evaluate the expression when x equals 10 and y equals 4. So in this kind of a pre-algebra exercise. So in one of these we're going to say x squared equals, and I'm going to say, well, x is 10. So I rewrite it, x squared equals 10 squared, right? Equals 10 times 10. And I have you do that because there are so many 6th graders that are still writing 10 times 2. No. 10 squared is not 10 times 2. 10 squared is 10 times itself, all right? So you multiply 10 times itself. So 10 times 10 is 100 circled. So x squared equals 10 squared equals 10 times 10 equals 100. Please don't just write x squared equals 100. That doesn't show me that you understand how this works. I want you to practice that. How about this one? How about evaluate the expression when x equals 10 and y equals 4? How about 3 times x squared? Well, I'm going to write 3 times x squared equals 3 times x is 10 squared. All right? Now, let's go over the order of operations. First off, in the order of operations, first thing you do is solve what's in the grouping symbols, right? Parentheses and those kinds of things. Secondly, evaluate powers. And then thirdly, you multiply and divide from left to right. And then what do you do as the last thing? You add or subtract left to right. So do we have any of that kind of thing here? Yeah, I have some grouping symbols at 10 squared, and I need to evaluate that first. So I'm not going to go 3 times 10 squared. I'm not going to say 30 squared. That's going to give me a totally different answer. I have to solve what's in here first. So it's going to be 3 times 10 squared is 100. We found that out up there. Now I multiply 3 times 100, and I get 300 circled. So 3 times x squared is 300. How about this one? A little more complicated. We have x and y involved with this one. You're going to evaluate this. 2x squared minus y squared. All right, so I rewrite it, replacing the x with 10, the y with 4. So I have to evaluate the powers first. So x squared is 100, 4 squared is 16. 2 times 100 minus 16 is 200 minus 16. 200 minus 16 is 184. Circle. So that's how you do those kinds of things. And Mr. Frazier is showing you the work to show in order to get credit for it. And now do remember, we have a test Friday, and Mr. Frazier expects you to use the, I'm sorry, that was last week. But the next time we have a test, we will be using this same kind of work that you show here. Well, you know, those are some of the things that you're having today in your practice. And by the way, look this video over again if you have a question, or you can go to classroom.com and online and get some answers to this section, prerequisite section. Or you can call me at 352-726-9347. 352-726-9347. Call me if you have a question. Message me on Edmodo. You have a great Monday. See you later.